properties as solid, liquid and gas. And let's study about solid, liquid and gas. First, let us gather some information about solids. What is solid? This table is solid. This pen is solid. I am solid. But is the water solid? No, it's liquid. So let's start up with the properties of solids. The first property of solid is that they have fixed shape. Like you can see, if you see that the table would not, if you put the table into another room, would the table change its shape? No, it won't. It's a solid. That means it has a tendency to maintain its shape. But compare it with water. If you put it in another container, then the shape changes. So, solids have a tendency to maintain their shape. But you must be wondering that if I hammer it, then it would break. Still, we had applied a force on it, so it had to break, and it maintained its tendency to remain a solid. Now let's move on to the second point, that is, they have fixed volume. Okay, that's a very clear point. A solid can never change its volume. Can I? No. Okay, let's move on to the very important point of a solid. That is that a solid is not compressible. Now, you just try to put this table in a very small room. It won't fit there. If you try to put it in a very small place, it won't fit there. That means it cannot be compressed. It's a solid. Now take only the example of a table. You put this duster inside a bottle. Inside a bottle with, small cap. You won't be able to put it inside because it's not compressible. You cannot compress it, press it, or you can just put it inside. Okay, so we have discussed the three properties of solid. One is they have fixed shape, fixed volume, and they are not compressible. Now you must be thinking by now, we can change the shape of a rubber band, isn't it? We can stretch it, or we can just mold it around. We can do anything around with a rubber band. Then how can it be a solid? But it is a solid, as when you apply some force on the rubber band, the shape changes. But when you just remove the force, the rubber band comes in its original shape. That means it has a tendency to maintain its shape. This means that it's a solid. Now just you must be thinking about sponge as well. We can compress it, press it and just mold it around. But it's also solid because it has minute air holes in it. So when we compress it, the air is escaped out, and when we just leave it, the air fills its compartments again. That means that it's a solid, and it has some variations because it's having the minute holes. That's why it's being compressed. So we have discussed about solids. Now let's turn on to liquids. What is liquid? Is this table a liquid or this pen? No, it's not a liquid. Only water and other things that they are like this. You can say that they are liquid. Now we'll study some things from which you can identify whether a substance is a liquid or not. One thing, they do not have fixed shape. You see, you take a liquid, or let's say water, and put it in, let's say this glass, and it would have a shape of this glass. Then put it into this glass, it would have a shape of this glass. That says that it does not has a fixed shape and takes the shape of the container. If you just spill it on ground, it would just be flat. That's what it is. It does not have a fixed shape, but of course it has a fixed volume. They have fixed volume. Even if you spill the liquid on the ground, its volume would remain the same. And even if it's in the glass, its volume would remain the same. So we can say that liquid have fixed volume. Now let's say the third thing, that's compressibility. They are moderately compressible. Which means that they are less compressible compared to the gas and more compressible compared to the liquids. So it's between, not extreme side or not extreme left. Now let's go on to my favorite topic, that's gas. Okay, gas is even simpler, I should say. Gas. What do you think about gas? Oh. Gas is something you're breathing. It's oxygen, nitrogen, in the air around you, hydrogen, etc. These are all gas. But you can see a gas. You can. Bromine vapors are visible. Okay, let's take up gas. That's all useless talks. They do not have a fixed shape. Nor fixed volume. Oh my god, they don't have fixed shape. That means you can just put this gas into another room and it would fit, because it will take the shape of the room. So it does not have a fixed shape. And volume, it does not have a fixed volume as well. Now let's talk about compressibility. It's very compressible. You must have heard about CNG, that is compressed natural gas. Loads of amount of CNG is compressed into a small cylinder that is transported to your homes. So it's highly compressible. Do you remember that once we discussed about the attraction of particles of matter? I did take up this topic because I wanted to ask you, my friends, what would be the packing of matter in all of them? If we see a solid, its packing of matter would be something like this. Oh, 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 oh. Tightly packed, tightly packed, tightly packed, tightly packed, tightly. Very tightly packed, so you can just not break it or just shake it, that's it. So it's a solid, it's very tightly packed. Okay, now let's take about liquids. Liquids are something like this, 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 this. These are liquids. I said now these are moderate, not so the extreme right nor the extreme left. These are moderates. And let's talk about gas. It's like this, 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 this and this. These are the real particles of gas. Okay, this is solid, this is liquid, and this is gas. Now, in gaseous state, the particles move around randomly at high speed, and due to this random movement, the particles hit each other and also the walls of container. So, you see, if there are many children in a room and they are quarreling about, they would hit each other and also the walls of that room. So same are with the gas, they're continuously moving and hitting each other and even the walls of container. That's what happens with gas. Now let's read further. It says that the pressure exerted by the gas is because of this force exerted by gas particles per unit area on the walls. Per unit area means that if this is container, then per unit area would be this, and they would exert the gas particles would exert a certain amount of force on this, because they would randomly be moving, hitting each other, and even hitting the walls of container. That's what they do. Okay. Now, we have talked about solid, liquid, gas, their packedness, and the solid exerting force on the walls of the container. You must all be wondering, can matter change its state? Which means that if it's a solid, can it convert into liquid, then into gas, and then nothing? These are the three states of matter.